What's up guys, Apu here and this is Whilelab YouTube channel. And here we are with day 23 of 30 days of code. In today's video we are going to solve binary search tree level order traversal. What's this about and how we're going to solve it? That's what we're going to find out in this video. So first thing, we want to understand what's going on. Okay, so the challenge will give us a linked list that would look something like this. Okay, this linked list would have 3, 2, 5, 1, 4 and 7. Okay, so what we should do is search this binary search tree in a traversal level order. That means is we don't jump into the next level until we consume the previous level. So we go with 3 and we go from left to right. So we go with 3. So if we are going to you do this, like if we are as a humans gonna do this without writing code, this binary search tree we'll read it like this. We'll take the 3, then we'll come left, read the 2, then we'll go right in the same level. We will not go down. We'll go right and then write the 5, then we go down since there is no more numbers. Okay, then we write the 1, then we go right, write the 4, go right, write the 7, and since there is no more nodes, so we can call this the result, or this would be a solution, the solution that our code should come up with for this sort of questions. So the question is how we are going to write code that solves this. So let's us find out. Okay, so let me bring in a new page and we will need this. Okay, so as we've discussed earlier in previous videos, that this is a linked list. Okay, and each linked list called or each number of those, this is called the node, this called the node, this called the node. Each node of those has two type data, left and right. Okay, so what we will do is leverage the power of a queue. Queue is basically a list where the first item in is the first item out. So if we added an item here, this is the first item, it's the first item gets out, the second item gets out, and so on. So this calls a queue data structure. We will use this to, so how are we going to do that is, first we will create a queue out of this number. Okay, so our queue, so we have we would need a list where we store the final numbers, and we would have the queue where we would process the linked list. So let's say this is our queue. So in our queue, first thing we would pass is the 3. The 3 would come up here, then the, okay, or shall I do it in reverse? Okay, let's say this is the n, this is where the numbers come in, this is where the numbers came out. So let's say we would start reading it from here. So the first number we will pass would be 3, then the 3, this is a node. Okay, this node has left and right. So for this 3 we want to first check its left. So we'll first add this first number we've got. So we'll add 3 over here in our list of numbers that we want to come up with. Then we will check its, like, I don't know why this keeps drawing. Anyway, so let me change the color. So this 3 would be, we'll write it here and we'll check its left. So its left is 2. So we'll come with the 2, write the 2. Okay. So how we do that, we will add the 2 over here. Over here, we would have the 2. So now we have the 2. The 3 have been popped out. We've got it. So now we would have the 2 over here. So we would come with the 2, and we would have the 5 over here. Okay. So from the 3, we had the 3 here. We would come up with the 2 and the 5 in this order. So we'd add the 2 and then add the 5. Then since we've added the 3 already to the list, now we would come check for the node which has the 2. So for the 2 we'll add the 2. Before we add the 2, we'll check if it has a right. It does not have any number in its right, but it has a left, so we'll add the 1 over here. Now we're gonna add the 2 to the list and remove it from our queue. Then we will come and check the 5. Does the 5 has any numbers in its left? We'll say yes, it has 4, so we'll add 4 here. Then we'll check, does it have a right? Yes, it has 7. Then we will add the 5 over here. Then we'll remove it from our queue. Now we'll check the 1. Does the 1 has any left or right? No, so we're gonna remove it from over here, add it over here. Then we'll check the 4. Does the 4 has any left or right? No, so we're gonna remove it from here, add it here. Then we'll check the 7. Does it have any right or left? No, so we're gonna remove it from here and add it over here. So that's the whole process. So that's how we are going to solve this. So let us jump into code and implement this. So first thing is we want a queue, which would represent this queue up here. Okay, so we'll create a queue and we want to start with the root, which is the 3. Okay, so we want to start with the 3, and we would have a list called numbers, and this list, which would represent this box over here, where we will add the numbers to be in the order we want, which is the level order, traversed level order. So anyway, then we will get into a while loop, and we will this while loop to keep running as long as queue still has items. So as long as the length of the queue list is more than 0, then we will keep looping. And here what we want to do is add the 3. Okay, first thing we want, as we did here when we had the 3 over here, we got its left and right, and then we added it to the numbers. That's what we will do over here. So we will store 3 in a node. Okay, and this node would be the latest or the last item in the queue, and indeed 3 is the last item in the queue. As you can see, it's in the right. So then we want to check if 3, which is the node, if the 3 has a left. If it has a left, then add this to the queue. But what we want to add, where we want to add it, we want to add it over to the left. Okay, so we'd insert it, we'd use the insert method and add it to the index 0, and what we would add is the node.left. So basically what this code does is check if the 3 has a left. It indeed has a left, which is the 2, and if it has a left, then add it. So it would add the 2 over here. Then okay, now we would have the 2. Then we want to check if 3 has a right, so create if statement, if node, which is the 3, has a right, then indeed add this to the list and index 0 the same, and add the node to right. So what would it do is add the 5 over here because it has a right. Now after that, since now we don't have the 3 in the second loop, the node would be the 2, because now we've using the pop we've removed 3 from the list, so we don't have this. The second loop we'd come check the 2, and we would see if it has a right. It wouldn't have a right. Since it doesn't have a right, this will not be executed. It has a left, so this will be executed, and it would add the 1 over here. So we'd have removed this. Now by now we'd have removed the 2 and removed the 5, and we've added them over here, and we would come check the 1. The 1 does not have any left or right, so we'll remove it and keep on as I've explained earlier. So at this point we should have a list of numbers which represents the same order we want, which is this 3, 2, 5, 1, 4 and 7. Let's run this code just to show you. Okay, yeah, okay. Here we should add node okay, to the numbers list we should append node.data. I forgot this which would add the 3 to the numbers list, which is this one. So we can call this numbers list, and this is the queue. Let's run the code now. It will give us a fail, but as you can see the list is 3, 2, 5, 1 and 4 and 7. Now the only thing we want is just add a star over here, and this star, what it would do is print the list like this instead of like this. So let's run the code and this should pass. And yeah guys, that's it. Let's submit the code, see ya. And voila! Congratulations guys, hope you've enjoyed this video. Don't forget to subscribe for more videos like this, and see you in the next one. Peace out.